Hello, everyone. Very honored to be here today. My name is Jonathan Chadwell. My background is a mix of healthcare analytics and real estate, where I've developed strong skills in working with data, problem solving, and communicating insights. Over time, I've grown passionate about data analytics and visualization, which is why I chose to focus my capstone project on exploring patterns in real world data. My goal now is to continue building a career in data analytics where I can take complex data and turn it into clear, actionable insights. I joined CodeU because I wanted to build on my analytical skills, especially with coding in Python and working with real world data. My goal was to strengthen my ability to take complex data sets, clean them, and turn them into meaningful insights. And why did I choose this project? So, having a background in healthcare, I've always been interested in how socioeconomic factors affect health. Historically, income levels have been linked to health outcomes. So, I wanted to explore whether that pattern showed up during the COVID-19 pandemic in Kentucky counties. By combining COVID-19 cases and deaths with median income data, I wanted to see how income tiers were connected to how communities experienced the pandemic. I gathered data from three sources: county level COVID 19 cases and deaths from the New York Times, and both median household income and population data sets came from the U.S. Census Bureau. Between the three data sets, there were over 2 million rows and 40 columns of data. I filtered it down to just Kentucky counties, removed an unknown county, and cleaned extra text and notes so that the data sets would merge correctly. The tools I used was VS Code and Jupyter Notebook for my coding. I used Python libraries like pandas for cleaning the data, matplotlib for was used for creating visualizations, and SQLite to merge the data sets. For the methods, I merged the three data sets using SQLite, linking them by county. I then standardized the COVID 19 cases and deaths per 1,000 people to make comparisons between counties fair. Finally, I created visualizations to help identify patterns between income levels and COVID 19 outcomes. So I ran into my biggest challenge when I used Python to sort cases by county. The top two were Jefferson and Fayette County, which would make sense since they are the two most populous counties in Kentucky. And I needed to come up with a methodology to compare counties of different sizes. After researching, I found that calculating cases and deaths per 1,000 people was the best way to have an accurate comparison. And this is the standard also used by the CDC and the World Health Organization. And to compare the counties fairly, I grouped them into income tiers based on their median household income. Counties with less than $20,000 were classified as below poverty level, 20,000 to just under 40,000 as low income, 40,000 just under 75,000 as middle income, and $75,000 or more as high income. This made it easier to see patterns in COVID-19 cases and deaths across different economic levels. So this is one of the six plots that I made. These are bar graphs that show the average COVID 19 cases and deaths per 1,000 people across Kentucky counties, broken down by income tiers. What we can see is that counties in the lower income tier had noticeably higher case rates compared to middle and high income counties. When it comes to deaths, we can see that there is a noticeable difference between low, middle, and high income counties. This suggests that income levels may have influenced how severely communities were impacted during the pandemic. So, in conclusion, when we look at Kentucky counties by income tier, there's a consistent trend. Lower income areas experienced higher COVID 19 case and death rates per 100,000 people compared to middle and high income tiers. The analysis doesn't prove income alone caused the difference, but it does show that socioeconomic conditions strongly correlate with health outcomes. Overall, the project highlights how data can uncover patterns that match what we often see in public health discussions. One of the biggest things I learned was how important it is to clean and structure data properly before any analysis can happen. I spent a lot of time making sure the counties matched across different data sets, handling missing values, and creating consistent columns. I also learned the value of using SQL and Python. It gave me flexibility to merge data sets in different ways and showed me how databases and data frames can work together. And finally, I learned how visualizations can really tell the story. The raw numbers don't mean much on their own, but when I plotted them, the trends became clear and easy to explain. This project helped me practice both the technical side of analysis and the communication side, taking complex data and sharing it in a way that anyone can understand. And that concludes my project presentation. Thank you for your time and attention today. If you'd like to connect or see more of my work, here's my contact information. I've got my email, my GitHub, and LinkedIn, and I'd be happy to answer any questions.